In the first of these videos, gravity turned out to be suppression. Near mass, fewer continuations are admissible. The local rate of succession falls, and histories drift down the resulting gradient. That drift is what falling is. In the second, entanglement turned out to be coupling. The joint continuation measure cannot be written as a product over the parts. The admissible futures of two systems are bound together, not because anything travels between them, but because they were never separable to begin with. Now look at what those two statements have in common. One of them suppresses continuation multiplicity locally. The other couples it globally. But both are statements about the same object, omega, the number of ways the structure can continue. Neither introduces anything the other does not already use. So the question becomes sharp. If gravity and entanglement are both about continuation capacity, is there a single quantity controlling both? There is. The temporal rate field tells you how fast succession proceeds at a location. The constraint parameter tells you how strongly continuation diversity is suppressed. These sound like different things. They are not. Equate the two rates of suppression, and the relation is fixed. The constraint strength is the inverse of the temporal rate. This is not a definition chosen for convenience. It follows from setting two independent measures of the same suppression equal to one another. And in the weak field it reproduces standard gravitational time dilation, which is what anchors it to general relativity rather than leaving it floating. Now we can do something that was not possible before. We can turn the dial. Start with an entangled joint structure. Only certain coupled patterns are admissible. Cross-system continuations, the ones that encode the coupling between the two subsystems, carry a positive dispersion penalty. Product-type continuations, where each side continues independently, carry none. Raise the constraint, and the exponential does the rest. The coupled patterns are suppressed. The independent ones are not. Push it far enough and only product-type events survive. The joint measure factorizes. The entanglement is gone. And notice what just happened. We did not add a mechanism to destroy the entanglement. We raised gravitational constraint, and the coupling died on its own. That is gravitational decoherence. In the usual treatment it is an extra process, bolted onto quantum mechanics, a gravitational collapse mechanism, proposed to explain why large superpositions do not persist. Here nothing was added. The decoherence is a structural consequence of suppressing continuation capacity. Penrose and Diósi proposed a rate for this on phenomenological grounds. Their expression and the one derived here have the same functional form. But the difference is ontological. In their account, gravitational collapse is a physical process superimposed on quantum theory. Here it is what continuation suppression looks like when you write it in quantum mechanical language. No new dynamics. No collapse postulate. No Hilbert space taken as fundamental. Which brings us to where this can break. For systems in which both quantities can be calculated, the two rates must agree. If they disagree, then this account of gravitational decoherence is ruled out. Not weakened, not in need of adjustment. Ruled out. That is a genuine empirical risk, and it is stated deliberately, because a framework that cannot fail is not physics. Suppressed locally. Coupled globally. Gravity and entanglement are two faces of the same continuation structure,